Hello, welcome to tutorial 8 where we're making something like Minecraft in Python with Petter Amland's Ursina 3D engine. Let's get Petter's name up here. Petter Amland. There we go. Do go visit his website and maybe become a Patreon of his for all his hard work making all of this possible. So in this tutorial, I've got a list of 10 things. I don't know if we're going to get through all of those, but here are the things that you've been asking for in your comments. So we want to correct the color of our terrain because I think it was way too green. It wasn't looking correct. Then we had some issues with, if you're quite new to watching this channel, perhaps that is in 2021 around July, there was an update from 3.5 to 3.6, and then a very small change because of an error that I made actually was working fine with 3.5 but not with 3.6. So if you're having any trouble with the terrain not working properly or textures, this video hopefully will be for you. We're going to get the terrain generating a lot more efficiently. I've made like just one line of code to make like a new gravity system, which is a lot better in terms of performance, which means we can have even faster terrain generating, larger terrain, which would be nice. But maybe we can fiddle around with that and try and improve it. It'd be great to make some caves. A lot of you are asking for perhaps layers in the terrain. I've no idea. Well, I know how to do that, but I've no idea if it'll be efficient or not. Because at the moment, we're really just creating terrain that you can't really delete. You can build on it, and then you can delete those blocks that we've built. We've got that system in our build tool system. But I've got an idea for how we can delete parts of the terrain by like deleting directly the vertices in the mesh, which I've had a little bit of success with, but who knows? Oh, the axe model, like I've got in the thumbnail. Someone had an idea. I'll have a look at a few of your comments in a moment. The fog, if we go like lower down in the terrain, maybe make it go darker. So if we get into caves and things, it'll be really dark. And what we could do is make the fog a lot thicker, and maybe change its color to black or something like that to give you a sense of darkness. Ursina does have a lighting system, so directional lights, ambient lights, things like that. And like everything in Ursina, it'd be very easy to sort out. Indeed, let's just bring up a website. If you go to the Ursina website and then just go to the cheat sheet, find that in its like documentation. This is fantastic. Again, presumably all put together by Petter Amland. So you can, anything you're interested in doing, if you just select it here, and it will give you some insight in how to sort things out. For example, we were just talking about lighting. There we go. If I go to light, it will give you a little example from the code, and then if you to show you how it's like working, and then if you actually click on this link at the top here, it will go to Petter's GitHub repository where the code actually lives. So when he updates things, or people who are collaborating with him, maybe you guys, this is where the code will actually be. So you can go and have a look at the code, and it's all open source, and work out how it's working. If you're not familiar with GitHub, maybe watch. I've not made any videos on GitHub, but maybe look at Daniel Schiffman's coding train. He has fantastic videos on how to use GitHub. Talking of GitHub, the code that goes along with my tutorials now live here. So if you forked the old repository, I'm not going to update that repository anymore, but I've just copied everything over to this new one. So the link in this video and all the previous videos, I've changed the links now. We'll go to here. So nothing's been lost. So basically, if you forked, that means like copied into your own GitHub account the old code or repository. I would maybe delete that one and fork this one instead. So this is where all the code and all the assets that I've used, like the axolotl models and textures and things. Everything that you see in these tutorials will be here, so you don't have to create them yourself. Obviously, it's much more fun and rewarding to create it all yourself. But if you're looking for things like, yeah, the nmap function or module, that doesn't exist. So because we made it. So if you want to use it in your code, you just have to say copy and paste this function into your code, or you could download this or copy and paste it into its own file and then put that in your Ursina, sorry, in your folder wherever your Ursina project is running from. Anyway, I think that was one of the things I wanted to talk about in the code. On the the new repo home of tutorial. So I've talked about all that. That one's done. We've already done one thing on the list. We should really do a little bit of coding, and there's one thing that we can do on here that's quite easy. Tidy the NumPy imports. So I just noticed these imports from NumPy import floor, absolute, sine, cosine, and radians. We could put all of these on one line by just doing a comment in between ABS or absolute, sine, function, cosine, and radians. Now we can delete all those. So we're just tidying up our code, refactoring our code. There we go. So that's done. So we've done a little bit of coding already. Trees. I've had some success with trees and some other things that I'm playing around with. Right, that's everything on the list, I think, that I've mentioned. What I definitely want to get onto is, the terrain issues. So I've just copied tutorial 7. So at the moment, the only difference is this list at the top from tutorial 7 and obviously what we've just corrected there or improved there on line 24. So it's exactly the same as tutorial 7. So what had we done? Oh, we started making mega sets and made our own subcube model. Right, let's just run tutorial 8 as I've got it. Oh yeah, there's one thing I haven't mentioned, which is about correcting the model loading issue. So we haven't got the correct texture working there. That's one thing I can notice. Our frame rate's at 20. Hello, Vincent. It's been like 2 weeks since I've seen you. And then there's our giant axolotl. I've forgotten what we called the giant axolotl. Did I call it baby? It's not important. It is important. It's the most important thing. All the coding is not important. The giant axolotl. Okay, Vincent's there. So, and you can see when there's like a jolt, that's when a megaset is combining. Remember that function is it's hard work for the computer. Okay, so we've got to sort out textures and things. Right, what I've now done is I've upgraded Ursina to 3.6. How do you upgrade? If you open up a terminal, there we go. I'm on a Mac, which I was told Ursina's not supposed to work on a Mac, but it's working kind of okay. It's Linux will work fine and Windows will work fine. So if you want to install or upgrade Ursina, maybe pip3 or pip install Ursina. So if you just write that should, and then enter obviously or return, that should install the latest version for you. Also, do I write pip3 freeze? That should give me a list of all the modules that I've got on here. So there we go. I can see it said Ursina. Why hasn't it given me the latest, the version number? Oh, where is that? Maybe it's up here somewhere. Oh, great. Okay. Unless it's on the screen and I just can't see it. I don't think so. It's in alphabetical order, isn't it? No, I can't see it. Okay. So that didn't work. So what that's supposed to do is give me, well, usually it's, well, as you can see, for every other module, it's giving me what version. And here I've just got Ursina and then at the GitHub page. Anyway, I'm sure there's another command that I don't know for getting the version. Anyway, I've got 3.6, so it's been 10 minutes, and no, I was going to say we've hardly done anything, but we have gone over the new repo and a few issues. That's important. Anyway, what were you going to do? Oh, right. So issue number 1, the terrain issues. So what I actually did is the following. Let me just read this. NB, nota bene, important note. This import is different from the YouTube, oh yeah, this one, safe combine tutorial video. In the 3.6 update for Ursina, a minor change in the combine function may cause a terrain to generate a piece instead of as expected. This safe combine function simply uses the legacy code from 3.5. So what that means is I've just created a file with the old version's code for the combine function, which is in our generate terrain. Should be just about here. Here we are. So around line 200, I'm using, instead of subsets combine, auto destroy false, I'm using my safe combine. So I've actually changed that code from the tutorial that you watched last time. So if you did watch it last time. So what we really want to do now, because that was just a hack, a little fix around, let's be really brave, delete that. And then we'll keep it exactly the same as it was last time. So now it's using the new 3.6 version of the combine. Let's just see what this is doing. Hopefully this will make things worse. I can't remember what stage this code is at. Oh, good. So this is a problem you might have had, and I'm going to show you how to sort this out now. Okay, what's basically going on is right at the top of our code, I was using load model and load texture, thinking that that was equivalent to when you create a model, an entity, and then set its model to, say, cube here. I thought that was equivalent, but it's not. Basically, one's creating like a superficial mesh, and the other is creating like a deep copy of a model with all the vertices and everything else. So basically, all we have to do is maybe we can do it this way, is not use load texture. So if we just do this, Ursina is clever enough, or Petter Amland was clever enough to have Ursina go and look for the respective file, be it a model or a texture, and then go and load it in the appropriate way. Let's just see if this works. So maybe before if you're following along with the code, maybe watch and see if it works. Let me mess everything up before you. Shall I risk the axolotl? I'll risk it. I'm not using my mouse, sorry. I may have been making a click sound. Okay. So I didn't realise you could do this. What I actually did was raise an issue on Petter Amland's GitHub, and he helped me out. So very good. Right. Okay. Let's play that. It's quite exciting. Oh, well, that's an improvement. So what we've got happening is the terrain is now generating the correct way. So we've got our models loading. Vincent's still alive, and our axolotl is still alive. So what this means is that everything will work correctly with the new updates. And we're now loading the models and textures correctly. Okay, so next bit is a bit more mysterious, which is why aren't we getting the texture? And I think that must be because I haven't applied the texture to the megaset or the subsets in the correct way. I don't actually know, so this is potentially more, even more exciting than the success that we've just had. If I get stuck though, I can always pause the video and go and look myself, and also I have got it working correctly in this mess around debug kind of file there, so I've got that on standby. I can close down tutorial 7. Anyway, so we're back in tutorial 8. Where do we want to look? So we want to look at where we create the subsets. Oh, here we are. So here are all our variables. So here we make our megaset, subsets, and subcube lists. Oh yeah, here's how the variables for setting how fast the train is generated. We want to come back and fine tune those numbers. And here's what we're looking for. So our ghost subset cubes, cube model, we're not giving them a texture here yet. Our subsets are getting a texture, the cube texture. So another possibility is to set that like something like name of the texture. I can't remember what that is. And also maybe it's in generating the terrain. We want to give the text, the subset a texture. The megaset is getting a texture there. But it hasn't got a model actually. Although I think in some testing that didn't matter. Anyway, let's go and try the first idea. So this is our second idea. We'll do it right here, I guess. Texture equals, am I calling it cube text? I'm calling everything else cube text, so maybe that's it. Oh, also the model, maybe our subset has to be the cube model, so that it might be an issue with the UVs. So these are the coordinates for the texture being applied. So cube text is our block texture. Right, let's play. Let's see if this works. This surely won't work straight away. So no, we're not getting our texture yet. And we have combined a megaset, sorry, so that's not working either. Right. So let's try the second thing, which was in our subsets, maybe they need to have a model, which is cube model. Actually, Anoush, thank you very much for your very, very helpful comments and issues that you raised on GitHub. You really helped me out. It was fantastic, and maybe you came up with a solution actually. Oh, it looks like oh, so it's beginning to work, but when the megaset gets applied, the texture's taken away. So something's working, and we've got a mystery white square at our origin at 0, 0, 0. Also, everything's way too green. We should have brown soil there. So that we're getting very close to now sorting out the colors actually. So let's just sort out the textures. So I think it's going to be on the megaset, which I'm treating differently. I'm kind of creating them, aren't I, on the fly. So it has got. So when we need a megaset on around line 210, I'm giving it a texture, but it hasn't got a model yet. So let's just try cube mod. And then, oh yeah, I was talking about Anush. I should go and have a look at your comments, Anush. Maybe my own code, old code. Oh no, cube mod is not defined. Is that because I haven't made it global here? Let's just try that. Cube mod. Unless it was just called something else. Oh, cube model. Well done if you were playing at home and you spotted that bug. Very good. There we are. Around line 210. So when we're ready to build a mega set, in other words, when the current subset that we're working on is the maximum number of subsets that we're allowed. Was it 420, or I've maybe made it a lot smaller for testing. Then we want to create a new entity, which is our megaset, and we place that on our megasets list. So I've saved that. I've used the correct name this time, and I bet this won't work straight away, will it? Oh, and we've created a megaset. I can just see it down the bottom there. Brilliant. Oh, so we've sorted out all of the terrain and texture issues. Oh, look at our original cube. We'll sort out this tiny bug later on. Basically, I shouldn't be kind of I don't need to create these models and textures like I'm doing. I need to make the original one invisible. Anyway, that's for later on. I'm happy with this. Right, so our infinite terrain now is generating correctly and with correct textures for all the new updates of Ursina. Very good. So what we do want to sort out is the actual colours of the cubes. First, they're all green, so we need to be shining white light through there. So at the moment, we've probably got 0 on the red channel, 0 on the blue, and 100% through green, or a variety through green. So let's go and sort that out. And what was the other thing? Oh, yeah, I think someone else commented, when we get really low, you can't actually see the texture. So we don't want to go too dark with our texture. That also might be to do with the fog thickness. So I had a few comments lined up. Where are we? Coding Master, hello. Which I've now lost. Where are you? Oh, Gaming and Facts, 3 days ago. Python file works fine, but the textures are not on the blocks. So we've sorted that out for you, Gaming and Facts. Oh, there you are, Coding Master. Could you do caves under the surface? I'm going to aim to do that. If not this video, definitely the next one. I'm getting this error when I try to put Vincent. Oh no, you need a giant Vincent, obviously. None type object has no attribute path. Oh, what did I say? Looks like the... What have you said? I have put it in the same file as my Python file. I'm still getting the error. Shall I show you my code? So I've had a look at your code. Oh, so I haven't solved this for you. Sorry. It gives the error when I load the entity. Unless the only other thing is maybe have you downloaded the chicken model from Sketchfab? It might be an FBX or something. It might be the wrong file type. It needs to be an OBJ file type, an object, which you convert very easily. And I'll definitely show you how to do that when we put the axe model on there. Anyway, I was getting distracted. From one particular comment. It was about going dark when we go lower. Oh, here we go. Ethan Rodriguez. Hello, Ethan. I have two questions. How can I add about 10 layers of cubes? We should definitely try and do that. If not this video, the next one. This goes very well together with cave generation. How do I destroy an individual cube from my terrain, which I've mentioned before? We'll have a look at that later on for proper mining. Oh yeah, there we go. If I go underground, it would be cool to remove or make the green colour a very less opacity and add light. Light should have shadows. Yes, so that's the idea of changing the fog, which would be really cool. Oh yes. Please make the tutorial which can move around the terrain without needing to jump. I did mention that in one of my videos, and we're definitely going to do that in this video. I'll do it as soon as possible. Okay, let's get back to the code, and I'll just close down that. And okay, so back in the code, what we want to do is go to generate terrain, and this is where we decide the colors, isn't it? Okay. I need to comment this a little bit better. Let's comment that here. Okay, time to decide colors. Right, so we're using the nmap function. Again, this doesn't exist in Python, and it's not a module that you can just import. Again, go to the link in this video, and it's there on the GitHub repository. I can't remember what video I showed you the actual code for as well. So basically, this variable g takes the y variable, which is the height of our block, and then I'm saying the heights of the block go from -8 to 21, and then set that color from 12 to 243. So, and then I add a random amount to that, which may make it lower or higher. So, so it could go 0. So that's why we can't see the texture. So we'll put that right up to 112. So the minimum it could be is 100, and then we'll leave that there. That's fine. Okay, and then we're not applying this to the red channel or the blue channel. So actually, we won't call that G. We could just leave it as G. We'll just put that as C for color. And then C, C, C. Right, let's go and run that. And so all of our textures, which we created to look much more like the real Minecraft, maybe slightly better? No. And there we go. That's looking much better, isn't it? And we've even got some variation in color, where you can see some of the grass is like darker, which is nice. If you want to increase that, which I do, let's make this 32, and then we'll get more variation. You don't have to change these two numbers, but I'm going to. What's 255 minus 32? It's about, I honestly can't do that. It's about 212. Please leave your answers in the comments. I can't do mental arithmetic. Never have been able to do it, never will be able to do it. Right, although I did find a book actually in a bookshop, funnily enough, the other year, which told you this wonderful method. I think it began with M, the method, for how to do really big sums in your head very intelligently. So I need to go and find that book. What I really want to do is teach my baby, when he's a little bit older, obviously, and it's got some symbolic competence for numbers and language. These kind of techniques, because can you imagine that if you're about like 4, 5, 6, 7 years old, and you know these efficient ways of doing sums in your head? Okay, we've already got a problem. What's going on there? Why is that randomly not appearing? Oh, now it is. Brilliant. I think the terrain looks a lot better. So we had a variation of like 64 or 32 darker, 32 lighter. And I think the terrain looks a lot better. It looks like the Queen's Garden in Alice in Wonderland. It looks lovely. Okay, so we've been going for half an hour now. I usually make these videos about an hour long, so we've got plenty of time. Let's go back to our list. Colour correction and see what we've done. Aren't tick lists like the most fun in the world? You can say done, tick. Right, what's that? Yes, we've sorted out the models and the texture loading. Although I didn't sort out that. I've forgotten his name now. Was it like coding and facts or something? You couldn't get Vincent in your terrain. Please let me know if you managed to do it and maybe how you did it. I'm very sorry that I didn't sort it out for you. More efficient terrain generation. We should do that. That's quite easy. I shouldn't have said that. Now it's going to go wrong. Trees, fog darkens we haven't done. Axe, model, cave, layers of terrain. Rodriguez. Thank you for that idea. Caves, new gravity system. Right, these two and 3, kind of go together. The new gravity system, what I mean is, I think this is Rodriguez's idea as well. Instead of having to jump, and instead of like hitting each like block, could we just step up automatically? And I think I've got a way to do that, and it should mean our performance is a lot better. So let's go and try to fiddle with the performance first. So in the place where our variables are, what we do is per cycle sorry, I keep trying to zoom in on the code and then it doesn't work the way I think it's supposed to. That's large enough, isn't it? You can see the text, right? Unless you're watching in the middle of the night on your mobile phone when you should be asleep. Maybe go to sleep. Everything will be better in the morning. Anyway, per cycle, that means we call the generate terrain function 16 times every update loop. And so if you increase that number, we're going to create a lot more. Let's increase it by a whole factor. And then the number of subcubes is how many subcubes do you have to make? Oh, sorry, do you have to like place in the correct position before you combine them into a subset? Now, the larger this number is, the joltier things will be when you create a subset. However, the bigger it is, the faster things are created. And then finally, how many subsets before we create a megaset that combines all the subsets. And you imagine all the vertices, that a vertex is like the corner in the mesh that describes the 3D shape. All of those, so it's going to be 160 subcubes times how many subsets you've got. So if we go to 420, it's going to be a very big jolt when we create a megaset. Probably about, at that number, maybe about 10 seconds, maybe a bit less than 10 seconds. But that means you can have very efficient running with a very large terrain. Right. So here's an issue. If you try to increase, the size of your terrain, you're probably going to glitch right through the terrain. And I told you number 3 goes very well. We need a new gravity system. We need okay. Oh, I thought we landed, but no. Okay. Let's go and sort this out. Let's keep that 160 at the moment. Or maybe, no. Okay, let's reduce it to 64. We can keep the number of subsets to 420. That won't affect us right away. Hopefully we'll be able to land this time. Okay. So when you actually move around, things go back to at least 30 frames per second. When you stand still, that's when the terrain generation properly starts going. You can see it's very fast, but as I'm looking around, actually it's not too bad, is it? It's saying 6 frames per second, but that's really not too bad. And when you start moving again, it instantly improves the performance. Now, when we've hit a ledge now, or a cube, and it makes us stop. So Rodriguez, Mr. Rodriguez, we should sort that out. And also, it will mean we can maybe have even faster terrain and maybe a silky 60 frames per second. That's what I'm hoping, without having to jump everywhere. Okay. So let's go and, okay, I won't go to I was going to go and tick my list off again, but I'll save that up. We need to go and create a new gravity system. So, basically at the moment, in generate shell, what did I call it? Generate shell. This very small function. Let's do some maths again. About 7 lines long. It creates just 3 by 3 blocks beneath us. So 9 blocks or cubes beneath us every update, so that we don't fall through the terrain unless a large job or performance hit is happening, and then the physics gets interrupted. So what we're going to do is comment all that out. We're going to replace it with our new gravity system. So basically what we're going to do is say, we're going to turn off gravity, first of all. So we can just say subject or player, whatever your first person controller is called. I call mine subject. Subject gravity is now 0. So we're just flying. But what we want to do then is say, use the Perlin noise to work out how high should the player be for the terrain block that it's standing on, that they're standing on, and then just move us to that height. Now, if we just move us to that height straight away, it'll look like, well, I don't know, should we just go and try that? And then we need to improve the algorithm a little bit so it looks like we're kind of moving up more slowly or moving down more slowly. So we do need the subject, so global subject, and then we want to say subject y, so that's our height, our y position, equals, and now we need to go and get hold of the Perlin noise function call, which we were using to determine the height of our secret invisible mini terrain beforehand. So we need the x and z position of our subject. So that's quite easy to get. We could just write it in here, subject.x, subject.z. Right, let's just see what that does. Well, we haven't fallen through the terrain, which is not surprising because our gravity is 0. Now it's the moment of truth. I feel like I'm on the moon. One small step for red hen. One giant leap for mankind. Right. It's working. We now look like we're very small, but we are moving up. So stepping up. But it kind of looks terrible. There's a weird optical illusion when you move down things, it doesn't look like you're moving down. So this is going to create a headache. So what we want to do is just move us to that like target position, so the height that we really want to be, which is maybe about 2 meters above or 2 units above the terrain. Oh my god, I was just on 71 frames per second. 63, that's on video. Confirmed. Or can be confirmed in the future when people don't believe us. Look at this. So we've got much more efficient performance. This is brilliant. Isn't this exciting? We can make the terrain really generate fast. Yeah, it looks like it's a massive terrain already. Let's go to the top of this hill. See how much terrain we've got. Okay. No terrain over there, but now it's generating. 59 frames per second, and I'm recording. Very good. Now the reason why that's improved is because the first-person controller code uses a raycast, which is like a little laser, and it kind of shoots down out of our pretend feet, and then it waits until it collides with something. So that's why we had to put a collider on our shell. And if it hits that, then it reports back that it's hit something, and then the first-person controller moves us down a little bit if we're far enough up, and if we've landed, it does other things. And so if we switch off gravity, it doesn't do any of that. So that's why we've got that improved performance. Okay, so what we now want to do, okay, so we don't want subject Y to go straight here. So let's say this is actually our target Y. So our target height is that. And then we want to say subject subject Y equals, now we're going to use a function called Lerp. And what Lerp does is take you from one number to another number. So it's a bit like a mapping function, I guess. So we're going to go from our current height, so wherever we are, either we're higher or lower, depending on whether we're stepping up or stepping down. And we want to go to the target height, but we don't want to do it straight away. And that's the point of this function. So then the third and very important parameter is how quickly do you want that to happen? Well, I want that to happen, let's borrow from, well, let's just put 0.1. 0.1 is a good number to put in when you don't know how fast something's going to happen, because then it'll be a little bit, hopefully quite slow. Now, we want to multiply this, because this is kind of happening as a physics thing every update. We want this to happen the same speed, no matter how fast our computer is working. And that's important if this code is being used on someone else's computer, because their computer might be slower or faster. So you'll have a different kind of gravity depending on what computer you're running, and that's not very good. You want it to be the same for every single person who experiences your code. So what we can do is use time.dt. And what that stands for is delta time. Basically what that does is read what is your frame per second, and then if it's really fast, say you've got a very fast computer, so very high frames per second, then this number will be lower, so it evens it out. And if you've got a very slow computer or a lot of performance issues is happening, then this number will be higher to make sure this is happening more quickly. So it kind of smooths out, and it's the same for everyone. So that's ready. Let's go and have a look. Lerp is included in Ursina, I think. Let's go and run that. I was almost going to say we haven't had any bugs yet. Like we've had some bugs, i.e. things not working, but we've not had any like errors straight away in the terminal. But I was too afraid to say it. Right. So that number 0.1 is probably a bit low, but now we're parachuting in, and it's a little bit jolty maybe as the terrain is generated. I just hit the G key. Do you remember that from an old video, which stops the terrain, kind of toggles the terrain generation off. So we can see it's actually very smooth when the terrain is not being generated. And are we going to land at any point? Oh, I didn't adjust us to be 2 meters higher. But basically what Lerp stands for is linear interpolation, which means the further away you are from your target number, the faster you move, and as you get closer, it slows down. So when we move, it kind of glides us down. This is not really what we're after. It looks like we're kind of flying. Although, oh, and it's not fast enough. When we go through the terrain, or we go through the terrain. So it wants to be fast enough to prevent us going through the terrain. Although we've got a little sneak peek of caves will look pretty good already, even though we've got one layer only. Right, let's just go and increase this number. Let's just increase it to gravity. Is that the acceleration of Earth's gravity? Is it 9.81? Is that right? 9.18? Let's look it up. Earth's gravitational acceleration. 9.807. Okay, let's use that. I have no idea if that's actually appropriate to 9.807, was it? I've also got memory issues. I can't remember anything. 9.807. Good. Okay. How does that work? Oh, and we need to be plus 2 meters. You know what? I'll exit, and then we want to say target equals that plus 2. Okay. That might affect where our build tool is actually. I can't remember what height we were before. Okay, we've already landed. And now, yes, doesn't that look good? It's smoothly bringing us up. Ah, we don't have to jump anymore. We can just step up. It looks, we've got like a little bit of a bob, so it looks like we're kind of like walking. I don't think, yeah, now because gravity's off, we can't use the spacebar to jump. So if you wanted jumping, we're going to have to code that later on. Let me know if you want jumping, and we'll do it. Or maybe you could create that yourself and maybe leave the code in the comments or as an issue on the GitHub repo, and I could use your code I could show your code in a future video. That'd be really interesting to see. Okay, that's great, and our frame rate is fantastic. This is good news. Right, let's go to our tick list. And I need to add something actually to it. What did I just say? 11. It was not jumping. I've already got that there. Oh, I wish I could rewind the video that I'm recording just to see. What did I say? I can't. Oh, damn, I can't remember. Maybe I'll remember in a second. Right. More efficient terrain generation. We've done that. We can maybe fiddle around with that a little bit more. We've got our new gravity system. Oh, that was it. I think that was it. It was the, we'll call that 3.1. The thing that I forgot, 3.1, which was check build tool position. Caves. Right, we've got about 10 minutes. We could try and do caves. Let's just go and have a look at the build tool, and I'll explain what we want. Well, I've got an idea for what we can do for caves. What we could do, oh yeah, bring up the build tool. Is that in position? Oh, I think it's in the right position. Very good. Yes, that's in the right position. Oh, presumably we can now, okay, so we've got a collider on those, and more to the point, we've got another raycast being from the first person controller being cast from like our chest or our head, so we can bump into those. But when we step here, okay, that one's good. That's stopping us as well. But because, yeah, that's not part of the Perlin terrain, it's not really interacting with our gravity system. We can't like jump up yet because we haven't got jumping. So what we need to do is kind of store that in a dictionary, and then in our gravity system just say, oh yeah, is there a block in that position, in which case add another 1 to our target height. And talking of dictionaries, oh yeah, I was going to do that in game. Talking of dictionaries, the idea I had was to store just wherever you wanted a terrain to be. Maybe we could use Perlin noise, so a different function to decide just random places, or predictably random places, or seeded places where we want a cave to be. And then when we're generating the terrain, say I don't want that cube there, I want it to disappear completely or to be very, very low. So in effect, you're creating a hole or a gap in the terrain. And we would use the dictionary like we've done for, oh, it'll be with the variables, like we've done for, the subdic for subcube dictionary with these curly braces. Whoops, I was trying to zoom in again and I scrolled around. With these curly braces, meaning that we store a key and a value, both a string. Well, they don't have to be a string, which is very, very efficient. So we don't have to go through a whole list or an array of every single cube we've generated and say, are you there, or are you a gap, are you supposed to be a cave? We can just go to the one item using our key on this dictionary very quickly and deal with it. So when we're generating the Perlin noise, we could do it in here because our gravity system is using generate Perlin. So in here we could actually ask, after we've done all the Perlin noise, we could then say, like here, is there a cave, call it a cave gap here, and then if so, lower the cube by, I don't know, 32. Or something. Smiley face. Oh, I've done a winky face. How exciting. Right, yes, that's what we'll do. Yeah, so just to remind ourselves, so to get hold of the terrain location, we've actually got the code already here. So this is just building a string, so it gets the X and the Z and then just places or uses the X and Z value, and then we're storing I if there is actually, in this case, a cube there. So what we want to do is make a test cave. Let's make a test cave. How long have I got? About 7 minutes, about 6 minutes. So we'll call it cave dictionary, cave dic, and then let's just hard code in the position. So we want to say it's going to be x9, z9. So we'll put it at 9, 9. And then we want to say cave. I think that's how the syntax works. And let's just have a look at the get. Yeah, that's what it's going to look like, isn't it? Brilliant. Okay, so we need to now go to Perlin noise, which I've lost. There we are. So we want to say if cave dictionary get, and now we put in our key. Oh, I should have copied that. Let's go and grab it from the generate. Whoops. The generate terrain function. I should have copied this. Oh, using these dictionaries is coming very handy. It's handy for checking if we've already generated a terrain block. That's why we originally used it. Now we're going to use it for caves. We'll be able to use it for trees, presumably. Sorry, I'm looking for the Perlin function. There we are. Let's remember that, 171. And what was I going to say? We could use it for... I've forgotten. Oh, I've forgotten again. What was we going to use it for? The caves? No, something else. I said trees already. Maybe it was trees I was thinking about. I don't know. No, it was something else. Anyway, if that equals cave, then y plus equals minus 32. So a drop 32. Now I've just seen a problem. No, I haven't seen a problem. I thought the problem was, oh, isn't it supposed to say like I if this position exists? But that was on a separate dictionary. We're using a different dictionary here, so we don't have to worry about overwriting whether a piece of terrain exists. Right. That surely won't already work. Let's have a look. I think I saved it. Invalid syntax. Okay. Oh, well done. Can you work out at home for 300 points what I've done wrong here? I've said if this position has a cave or equals this value, and it needs to be equals equals. Remember, in programming, just one equals means put this value inside this variable or assign this variable this value, whereas equals equals means are they the same thing? So it's very different from in maths. Right. Let's go. We've got 2 minutes and like 10 seconds to get this. Now I'm getting worried. Okay, x is not defined. Because our parameter is underscore. I'm using that. So we need underscore. Well done. If you saw that in the comments, if you saw that before I saw that, please put that in the comments. I'll give you like a like or something. Because that was impressive. I didn't see that. Okay. Is that the last bug? I can't see anymore. You're going to run. Oh, it's thinking about running. It's running. Okay. Here we are. Oh yeah, we're looking for 99. Oh, that's just reminded me of something that we could do. Get some text on the screen. Because right now it'd be really helpful to have like our location printed to the screen. So presumably I want to go about 9 steps forward. And then 9 steps to the right. It's like a treasure hunt. So it should be around here. Obviously, it just might not be working. Okay, so 2 things could be going wrong. One thing is I'm just not in the right place. Second thing is maybe I didn't write the dictionary properly. Or just our method, overall method is wrong. So let's just have a look. Cave dictionary. Let's float it in the air. So we'll put it 32, or maybe we'll just put it 9 units in the air. Then we'll definitely be able to see it if that cube exists. Our cave exists. That would still generate a cave. But we'd be able to see a cube floating. So that means something that I've done is not correct. Okay. Oh, we've gone over an hour. So what I'll do is pause the video, my recording, and then go and see if I can work it out, and then I can give you the answer, and then we'll finish the video after that. So see you in a moment. Hello, welcome back. Right, I think I found the issue. So, to debug, what we could do is actually say, well, what is the string that we're constructing? Is it what we're actually expecting? So we could say every time we're trying to check the locations from our dictionary, let's just print that string and just see if it looks like the location, i.e. x9, z9, that we're after. So let's just run that. And then we can look in the terminal, and can you see what the issue is? If I just exit the game. So we're not getting x9, z9, or -9 here. We're getting 0.0, so it's being stored as a floating point number, and we want it stored as a whole number or an integer. So so an integer is just like a natural number, 1, 2, 3, 4, 5, 6, 7, including 0 and the minus numbers, so -2, -3, and so on. So I think that's the issue. So to do this, as well as making our number a string to fit into this key, we need to then wrap it in int. So make sure we're casting the floating point number as an integer. That will also floor it, or will it round it? Okay, we might have some issues with rounding. Anyway, if we're not getting caves where we expect them, we might need to floor it, then then make it an integer, and so on. Anyway, so we've made it an integer. So now we should get our cave. Oh, I'm just looking for our cave dictionary. I should have recorded where I've got it. Another issue is the size of our file. It's way too big. We should have all these different file modules. Anyway, yes, we've got it there. What if we'll make a few more cave gaps? So we could go x10, z9, colon, put a cave there, and let's just copy that, and then comma to add a new key and value. 11.9, and then we'll go to 9 again, and we'll just go to 10. Oh, I could have copied a few lines, couldn't I? 9, 11. There we go. So we've got like a few gaps together, so it's a bit larger. And then I think during my debugging pause, I made them float. Yeah, we want it -9. Oh no, I did that on video, didn't I? We'll do it -9 so we can kind of like drop down into the cave if it works. I'm getting quite hopeful. Oh, the other thing I noticed while I was just debugging is I was looking at the terminal a lot, and when we combine, not subsets, but when we combine the mega set, I was again using this safe combine thing. If you're using my code, you may have seen this. So I want to, yeah, I've already taken care of this. I want to comment out the safe combine and use mega sets combine. So that's already there. It was commented out, but now I've reinstated it. And everything still works. So the textures are still working. Okay. Right. Let's go and see if we've got a cave. Can we be Batman? My tea's cold. Okay. We've got a cave gap. Can we get in there? Yes. So we're inside the cave, but you can now see an issue with our gravity system. Oh, it's so nice to be in a cave. Is that when we go back in line with cubes at the right height, we're instantly kind of interpolated back. And also when we drop, because there's a big difference, the linear interpolation or the lerping means if there's a big difference, then it moves us very quickly and then kind of slows us down. When we're at the surface, this rate is about perfect. So we have got caves, and we can now, you can play around with, I've lost them again. There they are, line 155. You can play around with how you're placing these. You can make like a little algorithm to decide that. I might do it in the next video. What did I just want to sort out? Oh, so what we definitely have to do is, where do I do this? In generate shell, which is now really our new gravity system. Let's comment that. Our new gravity system for moving the subject. We want to use kind of something like Lerp, but it needs to check something. I might just spend 1 minute. Let's just try something. We can say if our target y is actually the difference between our target y and our current position, current height. If that difference is greater than, let's say, 1, then we'll just write pass, and we can't step up that far. We can't step up that far. Else, we can step up that far. Let's just see what that does so far. It should mean that we can still drop down into our cave. Oh, we've just dropped through the terrain straight away. Why has that happened? I thought we started above the terrain. Yeah, we're 32. Let's just make it 320. I can only think that we're kind of dragged through the terrain and then it goes wrong. can I just go to get Perlin 00? What's it called? Gen Perlin. Oh, generate the Perlin height. I'm just trying to bring our subject starting position like closer to where we should be. This is weird, we're very low. If I start walking forwards, so we can't get any higher. Vincent's looking through the just take a screenshot of that. That might be the thumbnail or something. We can't get any higher. Well, that's a good thing. But yeah, this new attempt at improving the algorithm is not going very well. I'm clearly too tired. I need to go to bed. But I kind of wanted to have like a little bit of improvement this video. Sorry, at the end of this video for that. I've forgotten where I'm looking now. Yeah, I really need to go to bed. So, oh, it's in generate shell. So that's our new. We should rename this and rename the call of it to like gravity or move player or something like that. So that's our target plus 2. If the difference between that, so that's going to be the larger one. What if it's lower? Let's say it's minus. Well, let's say that's 0 and ours is 10. 0 minus 10 is minus 10. So it's less than. It's less than 1. So we should be lerping to the target position. I don't know why that's going wrong then. Maybe it's my past nonsense. I don't know. A equals 9. Put that on a new line so we can see what's going on. Anyway, what I'll do is behind the scenes work out what's going on. It's really strange. We're kind of like falling. Really far through the terrain to begin with, and then we're kind of being lost. So things were better when I was about 32 here. But no, try 16. No, we're falling. Oh, we're actually moving up. Or, sorry, or we're just generating terrain. It looks like it's getting bigger. Bizarre. So let's leave it at 32, what we had before. And just run it again. So presumably we just fall through the terrain here. Oh, I've definitely made up for having no bugs and everything going so easy early on. Yeah, that makes us fall through. So let's just take that off there. Actually, just just delete that. Just make sure things, as I'm leaving the code, because this will be in the link in the description for you in case it's not working for you, but it'll work using my code and the assets that I've put there. Remember, like nmap, you'll need that file as well, that Python module in your folder, the folder in which your Python file is running to work properly. Okay, so this is now working as we kind of expected, except we need to slow down gravity, as I was just beginning to try to do, but not successfully. Okay, right. Thank you very much for watching. Special thanks to Anush and Mr. Rodriguez and everybody else who comments and helps me out, especially to Vincent for looking through the terrain in our lowest moment to help us. Have a lovely week, and I'll see you maybe in the next video. Thank you very much. Goodbye.